Hey guys, welcome back to the episode 6 of the Open Storage project, a project which we are working at to be able to store at the open internet information that we don't need to go through the peer-to-peer network. So in the last the last episode, we create a mechanism so that we can store every 1 second a file, specifically at a GitHub repository, where we are going to be able to uh, retrieve from there. We are going to be able to store signals there so that can be retrieved by people following these signals or bots following these signals. Okay, so let's jump to the code and continue the work we were doing. Okay, this is where we were. I'm going to stop this. And this is the mechanism that we already tested and is working well. So no more testing over here. We already did a very basic error handling here. So this looks just fine. Okay. We also did previously a test to retrieve the file, and we have also seen our repository here. We have also seen that we are actually recording stuff. Okay, so things are being recorded. No problem with that. So what's next? What is next? Probably what is next is the mechanism not yet to send the signals into here, but we will need a mechanism to retrieve which was the file name that we managed to record in order for then continue the operation of sending the signal. So today let's go to the signal module. Not here. Okay, here. So today here at outgoing signals, today we have this module outgoing signals that is being used by inside the trading bot. Okay, inside the trading bot, every signal is needed to be sent is coming from here, and this go to this module peer-to-peer network start. That is the one here, which is essentially the module that that is going or is in charge of sending the signals. In fact, this module network start is not for signals. It represents the connectivity towards the start of the network. the peer-to-peer network is a directed acyclic graph. Okay, so the start of the network are the nodes in the graph that doesn't have any incoming connection. Okay, so something is not really very well put here, but anyways, as of today, we have this node that knows which are the nodes, which are the start of the network, that is bypassing the message, in this case of a signal, to this HTTP client node module. That is the one that actually is sending the message via HTTP to the network node, to one of the network nodes that belongs to the start of the network. So that's the overall picture here. And we will have to correct this because this is not really the flow how it should go. The flow, and on top of that, here we created a mechanism by which we are not sending all this. We are sending signals at every request, but also if we have a fail and we cannot send it, then this is going to store it so as to send it later. Okay, so this mechanism is going to be probably still useful for us, but instead of being called from outgoing signals, okay, it's going to be called as a callback when the storage managed to successfully save the file. Okay, so the flow, we will have to cut the flow and somehow from outgoing signals instead of coming here to the peer-to-peer network start, we are going to reroute this flow and we are going to send it towards the peer-to-peer, the storage. Okay, so the open storage. So when the open storage saves the file, then it's going to continue at the start, sending a message with the key, what we will call the key or the signal key. Okay, that is the one that is going to finally go to the peer-to-peer network. Okay, so we will have many mechanisms and a little bit of complexity, so try to follow me. I see at the same time there is one missing piece here. There is the piece where there is something in the middle that is missing, that is related to trading signals, and it's a module that we need to be loaded only once, okay, and to hold state at the task level, okay, because in fact these signals that we are sending here, we need to accumulate them into candles. Okay, we are not going to record a file full of signals, but we are going to accumulate signals into candles, in batches of candles, blocks of signals, with the candle being the minimum unit. And that is what we are going to store or try to store in a file. Okay, and so then there is one piece missing, and when the storage finishes, it's going to return the execution to this same module, probably, and this is going to send it to the network start that we have here, or maybe it send it directly to the start. We will see. Okay, yeah, probably we'll return it so that it's more, so that it's clearer. Okay, so let me think what is the next thing to do. We know there is a missing module, and we know that the storage needs to handle the responses. Okay, so we will prepare this open storage client. This episode we will prepare this so that to implement the mechanism to to call back whoever is needed to be called back once a file has been stored. Okay, so we have to make this guy ready for that. So let's do that. So we know when a file was saved when we arrive here. When we arrive here, it means that the file was saved. So here we can execute the callback of, let's say, callback when file is saved. Okay, and here we are going to send some information that we will need. One of the information, okay, so we're going to create an object for that because so we are going to do this file save, which is not good that it have the same name as the function. I'm going to rename this on file save and on file not saved. So the file saved the file save is going to be an object that is going to have file name, and the file name is going to be the file name that we used here, that is essentially the hash of the content, right? So that is going to be the file name, and also we need to identify the container which we use to save the file. So we are going to say storage container ID is going to be storage container ID, because whoever received this object, we are going to call file key, because somehow is the key to open this file. Okay, this is not going to work. So file key, and we are also going to add here a password. Why? Because we are going to encrypt the file, so that anybody that is monitoring these repositories, being the storage provider or whoever is monitoring in any way these containers, they won't have access to the signal information before they receive the password via the peer-to-peer network, which also delivers these file keys based on the amount of tokens that every participant in the network has. So the order is important. So this file key is going to be sent to this function. Okay? So where is this function coming from? For now, we're going to put it here. It's going to be a property of this object, and it's going to be initially undefined. So the new module of the signal processing stuff, what it's going to do is going to set a function here to be used as a callback function. And this is how the circuit is going to get completed. Okay? So on this side, it's almost complete. The other thing that I would do is to actually encrypt the content of the file. And we are going to use for that Web3, because it's a library we already have for encryption. And even though I haven't done it before, I don't think it's going to be difficult. So where is it? Here. With the file content, so let's think about this. We get here a timestamp file, and records to save is our content, right? So this is the file content, which we will get a hash. So my guess is that the hash, well, my question is if we are going to encrypt it after or before hashing it. Probably we will encrypt it before. It doesn't really matter. I don't think that is relevant. So once we have the file content, we will do this again. File content equals encrypt file content. So let's check for an example of how to encrypt using Web3. Web3 encrypt. How to encrypt a message using only the public key. So just a reminder that the network nodes are interconnected between them uh, according to the amount of token power they have. So it doesn't matter if somebody runs a network node and steals the password that is traveling over there, because he's entitled to see that password anyways, okay? Because the information arrive in a certain order, and once it arrives, he can act as a network node and continue distributing this file key, or he can consume the information and as they want. So I don't see a problem there. Okay, so how to encrypt a message using only the public key from a sign? Well, was not an example. Okay, so it looks like it is. Encrypts a private key to the web 3 key store v3 standard. So probably it's not what we want. At least not this function, because this function is to encrypt a private key. And the results are a bunch of stuff that well, maybe why not? It's just going to be a big stuff here in ciphertext. The thing is that if it is not a private key, probably it's not going to work. Okay. We can try it and see what happens. And if it doesn't work, then we will find some other encryption library and we'll use that. Okay, so for now, the way to do this is like this. So we're going to encrypt the file content and the password that we're going to use let password. We are going to generate a unique user ID. Okay. So let's see if I can find where do we have this. I guess here, utilities, miscellaneous functions, generate unique ID. I will get an example. And just like that, we got a password. Okay, so with this password, we'll get an encrypted file context. Let encrypted file content. We're going to generate the hash with that, and we're going to save that. Okay. And just to know if we can open this, we can decrypt this. Here we are going to do the inverse, and we are going to decrypt it. Decrypted file content going to be equal to and here it will go encrypted file content, and here we will do on one console log decrypted file content, of course. Good. So this is going to fail, so we're going to stop it there, but also here. Okay, so the test is this one. We want to know that this runs smoothly. So we just go and try it out. Run. Debug. Run. Okay, our file content is this. Our password is going to be this. Encrypted file content. Okay, it seems that it's not possible because it's not a private key. Cannot read properties, reading from read. Okay, so it's not possible to do it with this encryption library. So, okay, so we will leave this. I will do some research and come back with which is the most used encryption library. Maybe Node.js can encrypt stuff also. Let's check that out. Encrypt Node.js. if I recall, okay, so yeah, I recall Node.js had a crypto library. So algorithm key text, create cipher, algorithm key, cipher update text, okay. So what we will do is we'll create a small module. We will create a more a small utility module here, so that is available for anyone, so that we standardize this. Encryption, yes. Utilities, instead of miscellaneous, is going to be encryption. And we are going to have a function encrypt and decrypt. So we're going to use this across all superalgos, the same algorithm for everyone, and we simplify this stuff as much as we can. So here we will need text and password, and the same thing for decrypt, text and password, or I would say, yeah. So I understand that these are modules of Node.js, so not external modules. Okay, it seems that this was changing over time. I don't really understand this. What is this assert equal? Okay, probably. We don't need this assert, really. No, we don't. Okay, so what it's called key here, in fact, we are calling it password. So we don't need this guy. And text, we don't need it because it's a parameter. Then we can use a const here. Const. So it looks like this is the way. So create a cipher. Algorithm and password. Here comes the text. X. And here return decrypted. Okay. Okay. So we need to add this to the project schema file, this new module, so that it becomes available everywhere. So we got one that is similar to this one. We add one to the list. But in our case, this function goes like this. And the name, it will be encryption. Yes. Okay. So we will leave this here for a while. And in the same way that we are using this, we are going to use this. But here, instead of my miscellaneous function, we're going to use this. The property name is what comes here. and the function name is encrypt. So text and password is file content, and my god, I was replacing this. This was good. Okay, let's go again. Encryption, function name, encryption here, encrypt. So we're going to encrypt the file content using this password. And the result will end up here. We are going to hash the result, and it's going to become the file name. Okay? Then we will use a similar stuff here just to test the decryption of this. Decrypt, encrypted file content goes here, and the same password, and the decrypted file content should equal the file content. Okay, I mean exactly. So that's what we're going to ask. If the decrypted file content equals file content, then solve yes. Okay, so let's run this and see if it works. Cannot find module encryption. Yes, utilities encryption. Okay, it seems that I put something's wrong here. Why? It shouldn't be in TS. It should be in SA. Why did I put it on here? Why do we have two guys like this? Miscellaneous functions. Wow. That's surprising. We have two modules exactly with the same name. Okay, this should go here. But I'm curious now. What do we have here? Miscellaneous functions in SA utilities and TS. Truncate to this precision. Get dataset file. Okay, I'm not going to argue this. I just want my encryption to work for now. Run. Debug. Run. So here we go. File content is this. Password is this. And the encrypted file content is pretty much encrypted. I love it. So the file name, the hash of that is this. File path is this. And we are going to run. What happened? What about lag? We are using some deprecated encryption method. Okay, so what went wrong? What happened with the saving of this? Okay, it seems that this has a new entry, 1732. This is our file, and this is our encrypted signals. Beautiful. But why it didn't return here? We have to do it again. Okay, so we go again. It resolves okay. It comes here okay. Okay, this is failing. Storage container. Why is failing? Because storage container is inside this loop. So that means that these functions need to be inside this loop to get this context. Okay? Okay, that's not that difficult. But why this is out? Okay, whatever. We need you guys to be inside the loop here so that I can have you here, here, and here. running, debug, run, run, run. Okay. So this is our file key. This is what we are going to send through the network, okay? Through the peer-to-peer network, which is quite small, and it's 1 per second at most, okay, at most. So decrypt, beautiful. Is this the same? Yes. Okay, so now we're going to try to see what replace this crypto stuff, because this worked perfectly well and it works. But because we are talking about encryption, we wouldn't want to use something that is not the thing that it actually works. How do I replace the presented crypto cipher in OGS? Exactly what I want to know. I'm using blah blah blah. Replace crypto decipher by Y. It was due to security concerns. I don't want to write this again. So I'm just going to replace this or the other guy with this. Create this cipher. So we will check if this works. And what about create cipher? Also. So let's see if this is enough and it works for us. Debug. Run. Run. Oops. No, it doesn't work. The argument must be of type string or anything, blah blah blah. So now I have to redo this stuff taken from these examples. Okay, so Let's do it again. First, I don't like this. Okay, the encryption key is the password. And we have these constants. We are going to put them up here. Okay, it's not that bad. And this is to decrypt. And the password goes here. So we'll test this one. Debug. Oh my god. Embodied key length. What is this talking about? So it seems that the key, encryption key, put your password here. This stuff that this guy had. Maybe this has 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22. I don't understand. Maybe it's too long. Because my password is a little bit longer than this. Range error. Yeah. My god. So we are going to truncate the password. but not here, because if we truncate it here, it's going to travel without truncation. That's not good. Maybe I should generate a password randomly that is not a unique ID. Let's check. Generate password. No, yes. Okay, this looks good enough. Okay, we'll do it well, and we will add a new function here. Function random password. So here, the password, we will get it not with a unique ID, no. We will get it with a random password. Okay. So let's try this one. Mm-hmm. Yeah, okay. Embodied key length. I don't really understand this stuff, because this guy was using this. So what's the difference? This is the exact example this guy was giving. It just simply doesn't work. It doesn't work with the example doesn't work. So we need a password of 32 bytes. That's what these people is saying there. So let's generate password of 32. Of 32 on length. How is this password generated? Generate a random number. Convert to base 36. Cut off 8 character. The first example worked perfectly well out of the box. The second guy didn't make it out of the box at all. my god. Okay, 13 is the length. How can I get a longer password? Maybe add more. Add this plus this. From number 0 to 32. So now this should work. Okay, so password is this stuff. Length 38. I will remove this 0 point. So I will add here substring 01 from 2 to 32. So we remove the points and all this stuff. Looks better. 33. So now password should be 32. Yes, because here it has been 7. So now encrypt. Joder. Invalid key length. This is so annoying. Okay, we will use this guy. Well, it's a little bit frustrating that it takes so long, while the first method that is deprecated took so little. It just worked. But whatever. This is how things are, and that's it. So here we are supposed to have 32 a sequence to constant variable. What did I do? This was not a constant. Encrypted text. What is this? Let's look more carefully this example. Okay, text enter here. Here we go again. Here we go again. Encrypted context is this. File name, file path, whatever, run. GitHub says okay. Decrypted content, the same. Yes. Okay, so we finish. So we're going to comment this because it's the way we are going to use well, not really comment. We will need this when we read the file, in fact. Okay. Probably here. What will happen when we read the file, when we load the file? We will need to provide here the file key, not the file path, but the file key. Also, we will need the file path at the file key. No, we won't, because we have the timestamp inside the file. So with the timestamp, no, it is inside the file. So we will need at the file key the timestamp also, because with the timestamp we can recreate the file path. Okay. So when we load a file, we will use a file key object. Okay. The file key, we will get it through the peer-to-peer network, and with the file key let's resolve this so that everything is complete. Okay, the file name and file path that are needed here, we'll calculate it here. The file path is going to be the file key timestamp path from date time. Okay, and the file name, it is going to be the file name at the file key. So here, file key dot file name is going to be the file name. The file path, we will recreate the path with the timestamp. That's how we're going to get this. But once we get it, okay, we will have the encrypted file content. Okay, let encrypted file content. So from there, we will need to do this: decrypt the file content. So this goes here and the password goes there. But the password that we are having here is going to be the one that comes on the file key. Okay, so here we decrypt the content. In fact, this is going to be directly the file content that we are going to return, and we finish. Okay, so we are not going to test this because we already tested individually and it worked well. So I'm just going to leave it, remove it from here. Okay, so with this what we have done is that we have finished the project open storage. We have finished because we have been able to encrypt the file, save it at one of the containers. We implemented only the GitHub storage provider for now, but the other one wouldn't be difficult to add it here. Everything is ready. We are encrypting the file, hashing the name, creating a file key, putting the file inside a folder depending on the timestamp, and we are creating a file key with the timestamp file name that is a hash, and the storage container ID, and a password that is going to be sent over the peer-to-peer network, and whoever receives that will be able to use the load file function of this same module to retrieve the content of that file, whatever it is. This is powerful. This is powerful, and I like it. Okay, guys, so let's finish this episode now. I will continue with the trading signals episode series, where I'm going to modify the flow that we had before so as to be able to send the signals via this mechanism. For that, we need to create this module that is missing. Okay, so see you the next time, and thank you for watching.